So for today, we just want to start by going back to what we did in class on Friday, which was graphing our absolute value functions by finding the vertex, putting the vertex in the table, and then choosing x values that are above the x value of the vertex and x values that are below the x value of the vertex. So we can determine the y values and then graph. So definitely a good idea to look back at your notes from Friday, especially with finding the vertex in our absolute value formula. Okay, so pause the video and try it now. Okay, so number 5 on page 5, first thing we want to go back to is our absolute value function formula, which was y equals a times the absolute value of x minus h plus k, where h and k are the vertex. So that's what we want to find in our equation. Y equals the absolute value of x minus 2 minus 3. In that, this number here is our h value. Because the equation is minus h, I can see that minus, so the h is actually a positive 2. With that minus, we're thinking opposite sign. For our k value, it is plus k, so the only way to get a minus 3 is for the k value to be negative itself, negative 3, which means our vertex is the ordered pair 2, negative 3. I'm going to put that in our table. Because we have a leading coefficient, an a value of 1, it's an integer, we can really do any integer values of x. If it were a fraction, then I would want to try and be strategic so we can get integer y values. But since it's not, and our vertex, the x value is 2, we might just go above to say 3 and 4, and then go below to do 1 and 0. We could have spaced that out more if we wanted. Now we're just substituting in and finding our y value. So when x is 0, 0 minus 2 is negative 2. Absolute value of negative 2 is positive 2. Positive 2 minus 3 is negative 1. When x is 1, 1 minus 2 is negative 1. Absolute value of negative 1 is positive 1. Positive 1 minus 3 is negative 2. Then we have our vertex. X is 3. 3 minus 2 is 1. Absolute value of 1 is 1. 1 minus 3 is negative 2. Because we chose x values with that pattern, we should see the same reflected in our y. X value is 4. 4 minus 2 is 2. Absolute value of 2 is 2. Minus 3 is negative 1. Then we can just plot our points. 0, negative 1. 1, negative 2. 2, negative 3, 3, negative 2, 4, negative 1. Then we can connect with a straight edge all the way through and label. Some of you might be thinking that's a pain, doing that table every time, setting it up, and you're right. It is a pain. That's why we are going to learn how to graph without using a table, just by looking at what we know in our absolute value formula of how h affects things, how k affects it, and what a. Here we're graphing our absolute value functions without a table, so we want to go over our format of the equation again. Y equals a times the absolute value of x minus h plus k, and just kind of talk about what a, h, and k do to our graph. If h is less than 0, then that's going to be a shift to the left. So we'll see it shift our vertex to the left. If h is greater than 0, we're going to see a right shift. So talking about our x-coordinate of our vertex. If k is less than 0, that's going to be a shift down, right? So a vertical shift down. And if k is greater than 0, we're going to see a shift up in our y-axis. And then a, which kind of acts like our slope. If a is less than 0, we're going to see it open down the graph. If a is greater than 1, we're going to see a vertical stretch, which means it's going to be a narrower graph. If a is between 0 and 1, then we're going to see a horizontal stretch, meaning it's going to be a wider graph. Our vertex are the points H and K, and our axis of symmetry is the line x equals h. Okay, the vertex and our a value is really what we're going to use to graph. So we're going to identify the h and k. We're going to identify the value of a to determine if it goes up or down, plot the vertex, and then use that a to complete the slope. So let's put that into practice. For this, I always like to go up top and write down my generic form of the absolute value function, because it helps me to see, oh, minus h, so that vertex is going to be hk. Okay, so y equals x minus 2 plus 1. I can see my h is going to be positive 2 because minus 2 h, so positive 2. And our k is 1. And then the a value is right there, what's being multiplied to the absolute value bars. A is 1, so that tells me it opens up because it's positive, and the slope is 1. So we'll find our vertex to 1, and then just do a slope of 1 going up to the right, and then the slope of -1 going up to the left. Connect with our line, and we have our function. Okay, for number 2, I can see our h is -4, right? Because minus -4 is going to give us that +4, and our k is -2. So our vertex is at the point -4, -2. And then our a equals -1, so that tells me it's going to open down. So I'm going to see that slope of -1 going both ways. All right, let's get a little interesting here on number 3. Notice there's nothing being added or subtracted inside the absolute values and nothing outside. So that tells me our vertex is going to be at the origin. Okay, our a equals 2, which is positive, so it's going to open up, and then a slope of 2, so we're going to go up 2 to the right one. And then to make that other symmetrical side, we're going to go up 2 to the left one. Okay. Now number 4, I can see our h is -1, our k is -4, and our a is 3. So again, it's going to open up and be a narrower graph, a vertical shift. So we've got -1, -4, so then it's going to go up 1, 2, 3 to the right one. And then up 3 to the left one. And we'll make our graph. And that's it. Much easier without a table of values.